Research, implement, and manage engineering processes using secure design principles. Welcome to this module on secure design principles and engineering processes. Designing secure systems requires a proactive approach, ensuring security is built into every phase of development, rather than being an afterthought. This is known as security by design. In this lesson, we will explore key secure design principles, including least privilege, defense in depth, secure defaults, and zero trust. Let's get started. Secure design principles guide organizations in developing, deploying, and maintaining secure systems. These principles help reduce vulnerabilities, improve resilience, and prevent security breaches before they happen. To ensure security is built into systems from the ground up, organizations follow these principles. Threat modeling, identifying and analyzing potential threats early in the design phase. Least privilege, limiting user access to only what's necessary for their job. Defense in depth, implementing multiple layers of security to protect against threats. Secure defaults, ensuring default configurations are set to the most secure option. Fail securely, designing systems to fail in a way that doesn't compromise security. Segregation of duties, splitting responsibilities to prevent conflicts of interest. Keep it simple and small, reducing complexity to minimize security risks. Zero trust, or trust but verify, assuming no one is trustworthy by default and requiring continuous authentication. Privacy by design, integrating data privacy protections from the beginning. Shared responsibility, ensuring security is a shared effort between vendors, employees, and third-party services. Now, let's look at an example. A company follows the least privilege principle by granting employees access only to the data and systems they need. This prevents unauthorized access if an employee's credentials are compromised. Here's how to apply secure design principles effectively. Use threat modeling to identify risks early. Apply default security settings instead of requiring users to enable them manually. Implement multi-factor authentication (MFA) for all user accounts. Threat modeling is a proactive security strategy that helps organizations identify, analyze, and mitigate threats before they can be exploited. Threat modeling follows these key steps. Identify assets and entry points. Determine what needs protection and how attackers might gain access. Analyze potential threats. Assess how adversaries could exploit vulnerabilities. Implement security controls. Apply protections to mitigate identified risks. Here's an example. A software company developing a mobile banking app conducts threat modeling to identify risks such as phishing attacks and insecure API connections. Based on this, they implement strong authentication and end-to-end encryption to secure transactions. Here's how to conduct effective threat modeling. Use structured frameworks like Stride and PASTA for threat analysis. Regularly update threat models to address emerging risks. Involve security teams early in the development process. The principle of least privilege ensures that users, applications, and systems have only the minimum permissions necessary to perform their tasks. Least privilege reduces security risks in these ways. Prevents unauthorized access, limits exposure if an account is compromised. Reduces insider threats, employees can only access what they need. Minimizes damage from malware. Malware cannot spread easily if restricted by user permissions. Here's an example. An HR employee should only have access to payroll records, not customer databases. By enforcing least privilege, the organization prevents unauthorized access to sensitive customer information. Here's how to implement least privilege effectively. Use role-based access control, RBAC, to assign permissions based on job roles. Regularly audit access permissions and revoke unnecessary privileges. Enforce just-in-time JIT access for temporary permissions. Defense in depth is a multi-layered security approach that ensures if one control fails, others are still in place to protect the system. Defense in depth applies security controls at multiple levels. Physical security, securing buildings, servers, and access points, e.g. keycard access. Technical security, implementing firewalls, encryption, and endpoint protection. Administrative security, enforcing security policies, audits, and employee training. Here's an example. A company protecting its cloud infrastructure uses defense in depth by requiring MFA for logins, technical security, using biometric scanners for data center access, physical security, and enforcing security training for employees, administrative security. Here's how to apply defense in depth effectively. Implement firewalls, intrusion detection, and endpoint protection together. Use both physical and virtual security layers. Conduct regular security drills to test all defenses. Zero Trust is a security model that assumes no user or device should be trusted by default, even if they are inside the corporate network. Zero Trust operates on these core principles. Verify every user and device. Use strong authentication for all access requests. Apply least privilege access. Restrict access to only what's needed. Monitor everything continuously. Use logging, AI, and behavioral analytics to detect threats. Here's an example. A company enforces zero trust by requiring employees to verify their identity with multi-factor authentication before accessing corporate apps, even when working from inside the office. Here's how to implement zero trust effectively. Require for all user logins. Use network segmentation to prevent lateral movement in case of a breach. Continuously monitor access logs and suspicious behavior. Now, let's summarize what we've learned about secure design principles. Threat modeling helps identify risks early in system development. Least privilege ensures users only have access to what they need. Defense in depth applies multiple layers of security to protect systems. Zero Trust ensures every user and device is verified before granting access. Secure design principles improve security by reducing vulnerabilities and enforcing strong protections. By applying these secure design principles, organizations can develop safer, more resilient systems that withstand modern cyber threats. This concludes our module on secure design principles. Up next, understanding security models. Stay secure.